ever tried planning a complex multi-city group trip using a standard AI chatbot? Yeah, if you have, you know it usually ends in total frustration. The AI completely forgets your budget, it ignores your safety constraints, or it just straight up hallucinates flight routes that don't even exist in the real world. Well, today, we're going to explore a brilliant solution to this exact problem. In this explainer, we're breaking down how a system called PRAVAS uses 7 specialized AI agents to autonomously plan trips that are highly personalized, incredibly safe, and meticulously budget-conscious. Honestly, it's an absolute masterclass in modern AI architecture.
Here's our roadmap for the explainer. First, the multi-agent travel revolution. Then, orchestrating the perfect destination, followed by safety, flights, and hotels. After that, we'll hit experiences and budget loops. And finally, how to take this from demo to production. We'll start with the foundational problem AI faces, walk through the assembly line of these agents, and outline the exact steps to push this theoretical demo into a live, full-scale production environment.
Section 1. The multi-agent travel revolution. Building trips piece by piece. Look, traditional large language models are, quite frankly, terrible at complex, multi-variable travel planning. They just lose track of all the constraints when they're trying to juggle flights, hotels, safety, and budgets all at the exact same time. PRAVAS completely bypasses this by abandoning that whole one giant prompt approach. Instead, it uses a sequential assembly line of highly specialized agents.
The real genius of this system lies in its LangGraph state graph architecture. Instead of messy crosstalk, where Agent A tries to chat directly with Agent B and the context just gets totally lost in translation, these agents actually work in perfect isolation. They share their state through a strict digital clipboard called a PRAVAS state typed dict. What this means is that each agent just wakes up, reads its specific instructions from a single master trip record, does its one specific job, writes the new details back to that clipboard, and goes back to sleep. It's beautifully organized, and it completely prevents those chaotic hallucinations that ruin most AI workflows. So, when you actually set this into motion, it creates this beautifully structured pipeline flow. Step 1 covers orchestration and safety. Then it moves into Step 2, handling the hard bookings for flights and hotels. Step 3 enriches the trip with experiences, while making sure everything fits the budget loop. And finally, Step 4 brings it all together into the final itinerary. It systematically transforms a basic user request into a fully realized trip.
Moving on to Section 2, orchestrating the perfect destination, the master intelligence. The very first stop on our factory tour here is the orchestrator agent. Think of this as the master intelligence. It's responsible for evaluating every single possible destination in the database to find the absolute perfect match for what the user is asking for. And the orchestrator isn't just taking wild guesses here. It mathematically scores these destinations based on very specific weights. It prioritizes safety above absolutely everything else at 30%, followed closely by budget fit at 25% and mood match at 20%. Only after those core human needs are met does it even start to look at things like seasonality, hotel quality, and travel time. It guarantees that a destination is fundamentally safe, affordable, and matches your vibe before a single booking is even considered. Which brings us to a crucial number, 7.0. That is the baseline. If a destination's safety score falls below this minimum threshold out of 10, it is automatically skipped during the scoring phase. No exceptions. The system simply will not entertain sending a user somewhere that doesn't meet this rigorous standard. Section 3. Safety, flights, and hotels, the core bookings. Okay, so once the orchestrator has picked that optimal destination, it passes the baton down the line. But before any actual money is spent, the system applies one more absolutely critical check. That check is the safety agent. And let me be clear, this isn't just some friendly suggestion engine. It acts as a hard stop before any flights or hotels are even looked at. It serves as a strict safety gate specifically designed for women traveling. It pulls granular safety scores, and if a destination happens to fail this secondary, much deeper validation, the entire pipeline terminates immediately. Done. It routes straight to the end, no flights, no hotels, no itinerary. It's a fantastic example of building non-negotiable compliance straight into an AI flow. Now, assuming the destination does clear that rigorous gate, the process pivots seamlessly. The flight agent takes over to hunt down the cheapest or fastest flights via the Amadeus API, generating real, pre-filled deep link booking URLs for platforms like Make My Trip or Google Flights. Next up, the hotel agent steps in. What's so great about this one is how rigidly it follows hard-coded prompts. For example, it is explicitly instructed to never recommend a hotel without 24/7 security and CCTV. This is to ensure women-friendly accommodations across the board. This is exactly how you govern a large language model. You give it absolute, unbreakable rules. The unique specialization of each agent really shines here. While the flight agent prioritizes price or speed for the entire group, the hotel agent operates on entirely different logic. It strictly enforces those security features we just talked about, and it budgets exactly 30% of the total trip costs for accommodations. Even more cleverly, it calculates the required number of rooms using a hard-coded Python formula, taking the ceiling of the group size divided by 3. Why does that matter? Because it mathematically bypasses known bugs where LLMs totally fail at basic arithmetic. The AI isn't doing the math, the deterministic code is doing it for it.
Moving right along to Section 4, Experiences and Budget Loops, Ensuring Feasibility. Now we reach the fun part with the Experience Agent. This agent comes in to curate activities, but it smartly caps things at a sensible 3 activities per day, so the traveler doesn't get completely exhausted.
And it completely skips the generic tourist traps. It filters everything through specific traveler categories to guarantee the absolute right vibe. For women, it's safety first, well-lit venues, spas, and local markets. For senior citizens, it ensures low-exertion temples and seated shows with zero tight schedules. For families, it focuses on child-friendly parks and interactive museums. And for students, it's all about budget-first street food and offbeat adventures. And critically, these hard-coded rules cannot be overridden by the LLM. So you're never going to see a senior citizen accidentally booked for a high-exertion mountain trek just because the AI thought it sounded fun. The guardrails dictate the curation.
So once the activities are picked out, the budget agent runs the numbers. This brings us to the budget retry loop. If the budget agent calculates that the grand total, meaning flights, hotels, activities, food, blows past the user's budget, it doesn't just output a failed plan and give up. It triggers an iterative retry loop. It writes a note to the shared state, excludes the current overpriced destination, and forces the orchestrator to go back and pick the next best option. And it will do this up to 3 times. This retry mechanism is literally the magic of the whole LangGraph architecture. It acts as an incredible financial safety net, ensuring users never get handed a wildly overpriced itinerary. It even generates EMI payment options before handing things off to the itinerary agent, which then assembles everything into a polished, day-by-day plan with exact timings and entry fees.
Finally, Section 5, From Demo to Production, Blueprint to Reality. Let's dive into how we bridge the gap between this perfectly functioning theoretical demo and a live, scalable production deployment for the PRAVAS platform. The transition to production is surprisingly elegant, mainly because the code base perfectly mirrors the conceptual architecture. The destination cluster agent they promise on the front-end website, that is exactly our orchestrator agent working under the hood. The risk and compliance module, that's our safety agent. It's a true one-to-one match. The demo codebase we've just been exploring acts as the actual backend intelligence layer that the website is currently just mocking up with demo data. Bringing this to life isn't going to be some massive multi-month rebuild. With just a 1 to 2 week sprint, a backend developer can execute a very specific checklist to turn this demo into a live minimum viable product. You just wrap it in a fast API layer, switch the LLM to a production provider like Grok or Claude, implement Superbase so the agent's memory actually survives server restarts, plug in the real Amadeus API for live flight data, and connect the final output to the front end. It is incredibly actionable. We've definitely unpacked a lot in this explainer today, but I want to leave you with one final thought. As you think about how this sequential assembly line of specialized agents ensures safety, completely locks down budget compliance, and delivers hyper-personalized travel, step back for a moment. This isn't just about booking flights. Consider how this exact blueprint, multiple focused agents, a shared state graph, and rigid hard-coded compliance gates could solve your organization's most complex, multivariable routing challenges today. The architecture is already here. The real question is, what are you going to build with it?